Haloalkanes. No. Substitution by carboxylate group. Yesterday we were discussing the nucleophilic substitution reactions. This is one kind of substitution reaction. Like R alkyl group X plus, then you will take R C O O A G. That is silver salt. Silver salt of fatty acid. Silver salt of fatty acids. This is. You will get easily at room temperature R C O O R and then AgS. R is alkyl group, and you can take CH3, CH3, CH2, Cl plus CH3, COOAG, silver acetate, silver acetate. Then you will do it CH3, CH2, COO, then CH3. Little bit I am going to correct this because this C comes this side. This is the part of this C, not this C. Double O C C. So this one name is ethyl ethanoate. Ethyl ethanoate. This is ester. Esters are sweet smelling compounds plus AgCl. So these are alkyl group. This is also methyl alkyl group. This is silver acetate, and you got it ethyl ethanoate and AgCl. This is the ester. Okay. Next one reaction is reaction with KCN. Yesterday also we have discussed about KCN. Again, a reaction of haloalkanes with KCN and AgC, potassium cyanide and silver cyanide. Like R alkyl group, Rx plus KCN, alcoholic medium, alcoholic. In alcoholic, generally we take ethyl alcohol, that is C2H5S. In this medium, we carry out the reaction or tetrahydrofuran or THF. This is also ether. In presence of ether also, presence of alcohol, anyone you can use here. If you not remember the name of alcohol, simply you have to write alcohol or ether. Simply. Then you will get RCN plus KX. R here is also C2H5Cl plus KC. Here is alcohol. C2H5, Cn is the major product here, plus KCl, major product. Okay. Now next is so this is very useful reaction. No.
सर वो एरो के नीचे क्या लिखा है?
Alcoholic, ALC. This is the ALC, alcoholic. This is alcoholic. Alcoholic. No, not. The reaction is very useful to convert lower members to higher members. Lower members to higher members. So this is very useful. Okay. The reaction is very useful to convert lower members to higher members. You know, here is C2H5, here is C3. One more carbon added here. If you want to add the carbon in the carbon chain, you have to use KCN or NaCN also you can use. So this is ethyl, common name ethyl cyanide. Common name ethyl cyanide. IUPAC name propane nitrile 1, 2, 3. 3 carbon. IUPAC propane nitrile. Propane nitrile. This one is IUPAC. Now this is the A part. Now this is the B part. If the reaction RX plus AgCN silver cyanide alcoholic medium again alcoholic medium, you will get R and C. That is isocyanide. That is isocyanide plus AgS. Means C2H5Cl plus AgCN. Compound will be C2H5NC plus AgCN. This is isocyanide. Isocyanide. Or you can see isonitride. Yeah, propane nitride, ethyl nitride also. You have to add. Or ethyl isocyanide. There are lots of names. Question arises here, why this happens? It gives CN cyanide major compound. It gives isocyanide major compound. In yesterday class, I explained in AgCN, here is the covalent character. There is covalent character. If here is covalent character, so CN is not free. Here CN is ionic and it is free state, so you will get CN. Here you will get CN. Simply, I would like to tell you the behavior of CN. Behavior of CN. That's cyano group. Cyano group. That is C triple one N. You are getting number of non-pair electrons density here. If it will gain the lone pair electron this side. The situation will be C, double bond C. Then here is N, 1, 2, 3, 4, more density. So it is ambient. Once more density of electrons, more density of electrons in KC. So you will get RC. Here is more density. Here is more density of electrons on nitrogen. So it will give R and C. Here is isocyanide and it will give cyanide. So this is the difference. So this happens due to character of AgCN. This is covalent bond. This is covalent bond in this case. But if you discuss here in AgCN, KCN, that is this and this. So here is ionic bond. Here is ionic bond. In ionic bond, you will get easily CN, so you will get the RCN cyanide. It is a common, that is a major product. Major product. Here this one is major product in both sides. More density of electrons in KCN, more density of electrons on nitrogen, so it will give RNC. So you got it easily. Now, substitution of alkyl group by nitrite group, NO2. Next reaction is substitution of nitrite. That is NO2. This is a nitrite. RX means alkyl halide, as the name of chapter. Alkyl halide undergo a reaction with KNO2, potassium nitrate. KNO2. You will get RONO in this way plus KX. Again, R is C2H5. You can take C3H7 also. Then here is Br. Br or Cl, any choice of yours. You can take iodine also. The same Br. Here is K. I am going to open this. O and O in this way. You have to write it. So potassium here is negative, here is positive. So KBr moved out, and this will come to this. You will get C2H5 O and O plus KBr, potassium chloride. Okay. Name is ethyl nitrite. Ethyl nitrite. The reason is that if oxygen directly linked to the carbon atom and the nitrogen, this is called nitrite. If nitrogen linked with this carbon atom, then called nitro. Nitro compound, I will discuss the same fashion. These are nitrite group. If oxygen is linked, so this is O and O. This way, that is nitrite. Now, next, number 4. Now, nitroalkanes. Substitution by nitrogen. This is also same NO2. The difference is only NO. This is nitro group. This is the idea. Here is ONO nitrate. This one is nitro. If RX reacts with AgO and O in this way, so there is this condition not free. So this kind of reaction is not possible. In such a, what will happen? This is the electropositive character. So this electropositive character, it will attack here. It will attack here in such a case. So you have to write here, not AgNO2, then Ag R N O O in such a way. So in such a way, what will say? That is nitro. That is nitro. Here nitro Alkane. You can write not nitrite. If oxygen link, then nitrite. If nitrogen link with carbon, then nitroalkane. On the next slide, just means C. C2H5Br plus AgNO2. AgBr out. C2H5NO2, C2H5NO2 plus AgBr. You will see nitroethane. You will see nitroethane. Name of this compound. Clear? Now, reaction with alkynes. And what kind of compound they will give? First of all, you have to convert alkynes into sodium alkyne ion. Reaction with alkynes. Reaction with alkynes. If reaction with alkynes, you will do. So in such case, what will happen? R C triple bond CH. In alkynes, this hydrogen is acidic. This hydrogen is acidic. So it will react with easily sodamide, Na, NH2. That is the base. So this will come with this, and sodium comes at this place. Then R C C C N. Name of this compound is sodium alkyne ion. Sodium alkyne ion. You got this. And plus NH3. Now RX react with sodium alkyne ion. We can write reverse this Na C triple bond C R. Negative, then positive character, it will move dot means. Then you will get R C triple bond C R plus Na. Okay, you got it both are. So that is alkyne. Alkyne means number of alkyl group increases here. Like CH3, you can take, here is Br plus NaC triple bond C and then C2H5. Simply NABR moves out, you will get CH3, C, one methyl group also added here, CH3, C, triple bond C, then C2H5. Name is 1, 2, 3, 4, 5. Pent to ion. Pent to ion. Please note down accordingly, or you can get the screenshot of this. If you want to take, you can take the screenshot. Now, reaction with amino group. The amino is ammonia. Now, reaction with amino group. That is ammonia. This reaction is not easy, but that is called Hofmann ammonolysis. Also known as Hofmann's ammonolysis. Hofmann's ammonolysis. The C2H5 here, then NH3 you can write as NH2 ammonia. HBr moved out, then C2H5 NH2. That is the primary amine. C2H5 NH2 ethylamine. That is called ethylamine plus HBr. Similarly, again it can be C2H5. C2H5 and H, one more H. Similarly, you can write here also. And then again, Br C2H5. Then this also with this. Now secondary amine C2H5 NH, then C2H5. This is called secondary amine. Secondary amine by this method, or name is N-ethyl, IBC name is IUPAC name, because this N2 link ethyl, N-ethyl ethanamine, N-ethyl ethanamine. Okay, you can do that. Now, in second case, third case, one hydrogen left here. Again, this will involve. That is called exhaustive ammonolysis. We can say exhaustive ammonolysis. Maximum ammonia can react with this one. Now, C2H5, again H this, C2H5 plus Br C2H5. HBr moves out again, then you will get tertiary, that is R, N, R, R. Here I have taken C2H5 as R. This will represent R to symbolize this. The symbolic representation, you can do it already. This is also that is I have taken this to represent that is called tertiary amine. Okay, the NN dialkyl amine, or you can say N diethyl amine. Similarly, N-ethyl ethanamine. Same, you have to name this compound also. Okay. Done. Now, next we will discuss about the same properties in elimination reactions. The elimination reactions. The role of KOH. Elimination reactions. What are elimination reactions? When water molecule HCl, any molecule moves out from the parent compound, that is called elimination reactions. Or we can say them solvolysis reaction simply. How you will do this? C2H5OH when when C2H5Cl C2H5Cl will undergo reaction KOH alcoholic. ALC means alcoholic. Alcoholic KOH. In presence of alcoholic KOH, then this HCl will move out H2. You will get CH2 double bond CH2 plus KCl and then H2. So from this beta hydrogen and alpha carbon chlorine moves out. So that is called beta elimination. That is called beta elimination. Beta elimination. Now I will explain what is beta elimination. Mechanism, how this reactions happen. Mechanism, the process of the reaction. That is SN2 kind of reaction, not SN1. This called H, 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 C, H, Cl, and this. This we are reading in this one. Now KOH, this OH we will take. This OH attacks at this carbon. This is the base. This hydrogen. This hydrogen gives its electrons to here. And this is the alpha carbon atom. This is alpha carbon atom which chlorine link. Beta carbon atom where hydrogen moves out. From which carbon atom hydrogen moves out, that is called beta elimination. In beta elimination, hydrogen, beta elimination, what you will do? This chlorine moves out, this hydrogen moves out. Simultaneously with the process, you will get HC, H double bond C. With this HOH, this H2, and this is potassium lead with this Cl, that is KCl. So this is the reaction process. Okay, you should come to know. The reaction is also known as dehydrogen. The reaction also known as dehydrohalogenation. dehydrohalogenation. Because one hydrogen and one halogen moved out, so the reaction is also known as dehydrohalogenation. Or one to elimination. One to elimination. You can also, because one carbon atom, two carbon atom. Here hydrogen moves out from this halogen, one to elimination. Or you can say alpha and beta. From beta carbon, hydrogen comes with OH, that is the base, so it gives water molecule, so it's called beta elimination. Okay, but both elements will not come out from one carbon atom. Never think about this hydrogen and this halogen from one carbon never involved. Always hydrogen will comes out from beta carbon and halogen or any other group if present here, it will be comes out from alpha carbon atom. Okay, this. Now, one more little bit difference in this, how we'll do it and what kind of compound and what is there's the one reaction. One more important reaction. If you are taking the compound CH3, CH2, CH, Br, and then CH3. So, what I said you, this carbon atom is linked with bromine, that is alpha carbon. So, this one is alpha carbon atom, this one is beta carbon atom, this side also beta carbon atom, because these are the 1, 2, 1, 2, you can see. In such case, hydrogen can be moved out this or this. There are two choices. Hydrogen can come out from this side. Again, I am going to modify here also. This H, this H. And here is 2. So their choice of this Br with potassium, this hydrogen can be moved out here, and this also. There are two options. If this will go with OH, or this can go OH. OH can get this also, this side, this also. Now see both cases. If this comes out, then this retained in such case. CH3, CH2, CH double one, CH. If this moves out, then CH3, CH double one, CH, CH3. So both compounds are possible in such kind of compound. This is a very important. You have to learn. Why this reason? Because it is in between of two carbon, then double bond, so it is more symmetrical. Always symmetrical compounds major. Or this is unsymmetrical. Unsymmetrical compound. So this will be minor. So this is major and this is minor. Got it? No. Next, we will discuss again one more E2 reaction, that is biomolecular. This is also biomolecular reactions. Now, depends upon the strong base. If strong base will act on biomolecular reactions. Again, login once again, login again.